This
designated
conference will now be recorded.
project engineer on the Bristol Junction Remodelling project. Yeah. And I'm sitting with
Zuliani. Yeah, I'll sort it out.
So what we'll do today is just go through the agenda, some of the scope, how the staging strategy was set up, talk about the contractual arrangement, and then kind of go into the enabling stages and how the scheme was constructed, some of the engineering challenges, and also the lessons learned and achievements. So Bristol East Junction is located in the Bristol city centre and compromises of 4 tracks that come from Bristol Parkway that connect into the Filton 4 tracking project that was recently done, and you've got 2 tracks which are the MLN lines that go to Bath and then on to London. This diagram shows basically the footprint of the layout of all of the area that we renewed, and the colours basically break down the different stages that we had in terms of enabling stages and also the big blockade. So the orange at the top right basically shows this was stage B, which was basically track, plane line, and a ladder that was installed early in April 2020. We did some plane line renewals on the MLN. Then the yellow section was 5 turnouts that we installed over the Christmas period. The green below that is Kingston Road sidings, which was taken out of use at the Christmas time and basically built offline, and that was reconfigured. And then the rest of the junction was split into different stages, and this is how we broke up the 8-week blockade, which happened last summer. As you can see from the diagram, also there are a number of structures that we've listed out where we had some engineering challenges, which Ben will go into, and basically the whole layout was reconfigured to allow for passive provision to the timetable up to 2043. So if we move on to the next slide, here we are. So Network Rail were the key player in integration in terms of this project. It was a hub and spoke setup in terms of contractual arrangement. Our principal contractor was SRSA and Colas, and we worked closely with them, with their design partners AECOM, to deliver the track and civils elements of the work, and also points heating. We had Amco Giffen, who were the major civils contractor, who installed the big signalling gantry that we'll talk about, and also a number of walkways and lighting. Alstom were the signalling contractor that did the data change, power, telecoms, Resonate, the control systems. We had a number of different contractors doing cable diversions, namely Telen and SSE, and then we had Pennant doing driver training material. So we had a lot of different contracts with various players, and Network Rail sat in the middle integrating all of them. If I move on. So the scope of Bristol East Junction, it was the recovery of 58 existing life expired S&C units, which were replaced with 50 new units, and the layout was reconfigured for the future timetable. There was plane line installation, and we discussed Kingston Road siding that was remodelled. In terms of other assets, we had a lot of civils infrastructure going in terms of the new Bristol East Gantry, demolition of line-side buildings, COPA adjustments, driver walkways. We had signalling structures going up in terms of a cantilever and 16 new signals, loke suites, cabling. We had also a number of different cable diversions, with an 11 kV cable being moved out of the way for some of the work in stage A, and then we've got a number of different telecoms installations and lift and shift works. So what was the purpose of Bristol East? Well, the benefit was we were reconfiguring the layout to meet the future aspirations for the timetable up to 2043. The layout was life expired, and we reconfigured the layout with new S&C units that fit the modern standards that are used today. It was a reduction in S&C units, so therefore improving kind of access for the maintainer to get in and access some of the units, and we removed the bottlenecks, so we allowed for fast services to go through certain platforms and slow ones to stop in the higher number platforms. The project also provided passive provision if platform 0 ever is installed, and also allows for passive provision for the Metro West schemes. So just quickly, this is the existing layout. As you can see in black, there are 6 main lines that go into the station, and with the new layout there are 7, including a new head shunt, and the gantry was replaced to allow for a 7-line gantry structure to be installed. The scheme was broken down into a number of stages. So we have 5 enabling stages, stages A to E, and these were all done ahead of the major blockade, which was stage F. And the reason this was broken down into 5 enabling stages is we were trying to install as much infrastructure as possible to reduce the size of the blockade, but without the need of a data change. So all the stuff that we did in stages A to E didn't require a data change. And then when we got to stage F, which was basically the red area that you can see on the screen now, that was all of the new S&C that was installed, which required for the signalling infrastructure to come up to date so we could run services. So this is some drone footage just before we started the blockade, but after we finished all of the enabling services. So we're coming up from Bath Spa on the MLNs. So this was the plain line sections were done in stage B, and then to the left you've got Kingston Road sidings, and this was built offline, but as you can see, the Colas, the constructor, had already started delivering panels and started building up some of the S&C units on site, so we could get a jump on when the blockade started dropping those panels into place. This is where the 2 lines kind of converge from the MLNs into the BSWs, and this work was done over the Christmas period. You can see the kind of old dirty ballast of the tracks that we haven't installed just yet, and that's all kind of taken out in the blockade. To the right you can see this kind of playground area. This was used as a temporary access to allow for people to come onto site, and some temporary visitors platforms were put in, so we had people on site not using, going on to the construction area. Just at the bottom of the screen now, we've just gone past the 7-line gantry that was installed in terms of the structure previously at Christmas, and the new head shunt is being used to build up more panels. You can also see to the right this yellow walking route, which is where we relocated an 11 kV cable and provided access into the station. And as we turn into Bristol Templemead Station, to the right of the IET train, there is platform 13, and that was fully renewed prior to the blockade to allow for compliant gauging all the way through the length of the platform. And as the camera turns, you can see this flat area. This is where the eastern entrance was used to basically take off some track panels and put in a new tunnel so that we can connect the this side of the station through the subway. So I'll move on. On top of the scope of Bristol East Junction remodelling and the area around Bristol Templemead, there was a requirement for us to facilitate the use of servicing into the Arriva Train Care depot. So when we took out the tracks in the 8-week blockade, it meant that the Barton Hill depot that's used today didn't have access. So the project had to build a temporary depot about 2 miles away from Bristol Temple Meads that had the facilities to allow for Arriva Train Care to undertake servicing and cleaning of cross-country trains in a different location. The temporary depot allowed for the safe service and repair of cleaning of 6 trains per night. And what we managed to do was use some of the old panels that we took out for some of the enabling stages in the temporary depot. So we kind of recycled some of the materials. The scope in the depot also included CET water facilities, new walkways and lighting. So we made a complete temporary depot just for the purposes of the 8-week blockade. Some other scope that was added in kind of late in the day was some platform extensions at Bedminster. Platforms 1, 2 and 3 were required for extensions for 5-car trains to stop at Bedminster and then turn back and go to the west. So the scope of works included 50 metres of platform surfacing, copa replacements, and also temporary lighting that was installed with signs and gates that needed to be moved for the timings of the blockade.
Thanks, Molly. So moving on to the Stage F partial blockade, which was delivered last summer. In terms of the core track scope that was delivered by SRSA, there was approximately 25 to 100 metres of copa adjustments on the east side of Bristol Temple Meads Station. This was due to the amount of S&C located just at the throat of the station. So we had to tie in for say approximately 25 to 100 metres into these platforms. There was also a larger rebuild of platform 15 due to the amount of slew away from the platform to achieve offsets, compliant offsets. In terms of the track, 34 S&C point ends were installed during Stage F, of which the majority was HPSS POE and all the associated plane line. Then there was also the points heating and transformers. In terms of the additional track works, there was also installation of lubrication units, lerps, and all of the formation treatment. So in terms of a timeline for the blockade, this is known as partial blockade because throughout the 8 weeks it was in operational use for part of the blockade. So, and this was enabled through several 6 entry into service points. And this basically allowed for part of the station or junction to be in use. And only 5 days of the whole 8 weeks was actually, there was no services or it was completely blocked. And this was enabled through the use of adjacent line open working. And these entry and service points, which I'll go into a bit more detail later, but the main ones to look at was entry service 1, which enabled the filter lines to be blocked, which are the top lines in that diagram at the bottom, and the main lines to be open for operation. And then entry service 5 allowed for the junction to be flipped with the filter and reliefs coming into use and the main lines blocked for work. And then entry into service 6 was the final commissioning of the entire junction. So going into a bit of detail of the staging, it was split into 4 main parts. Part 1 was the first 28 days of the blockade, and this started with entry into service 1, which, as I mentioned, allowed for the filters to be blocked, which is shown in the lighter blue colour on the diagram, with the airload barrier in effect on the down filter main. This basically allowed for the main lines to be in operation to allow services to operate from London all the way through to the west. So all the associated track work took place on the filters, including the signalling works, including disconnections and reconnections, and there was also civils works on that side of the junction, including the installation of walking routes and troughing routes. Part 2 was further split into 3 subcategories, 2A, 2B and 2C. In terms of 2A, this was 1 day, and this was enabled ES2, which was the removal of the existing gantry. So as shown by the video footage, the new gantry was sitting over the top of the old one. So during this time it was removed, and then this period also allowed for support to the data change, which takes part in the next part, and also work began on the installing new signals on the new gantry. So part 2B was the entry service 3, which was the TS11 data change. So this was a 1-day period where the whole junction and station was blocked. And work also continued on installation of the new cages and signals. Part 2C was the final 7 days of part 2, which was the installation of the central line in the junction, shown by the light blue, so the downfill main, and allowed Alstom to undertake their testing and commissioning of the Filton relief lines in preparation for ES5, which took place at the end of this part. Moving into part 3, so at this point the Filton reliefs are now in operation, with the main lines blocked for track works. In terms of services or operation, services could come down from Filton Way and travel through the low numbered platforms of Bristol Meads towards the west. Additionally, there was also civils works to the end of platform 9 and 11, where a new signal gantry, signal cantilever was installed, and then there was also the associated troughing and walkway works. And then also during this part, we had the interface with the eastern entrance, which was being delivered by Van Little on platform 15. And then moving on to part 4, which was the final 4 days of blockade. This was fully blocked, the junction was fully blocked in the station. This was the commissioning of the entire junction, which was delivered as AS6 and was delivered on time. In terms of CDM arrangements for the works, there was no concerns for the majority of the Bristol East footprint. However, there had to be specific deconfliction required at the station due to the number of projects that were sort of ongoing at the same time. So it included the Bristol East project, the roof renewal project, and the Eastern Entrance project. So a Blockade CDM integration plan was produced and signed up to by all the parties. And within this, it included maps that detailed all the sort of demarcation barriers and hoarding that would separate work sites, but also, as I noted, the station was in operation for a large part of the blockade, so it ensured that the public could be safe during the period of work. So this is a time lapse showing the construction staging. So it's located, the camera or the camera's located on the new gantry, currently looking towards Bristol Mead Station. And as you can see, part 1 has commenced with the removal and installation of track on the Filton lines. And as you can see, the panels have already been situated on the headshunt line, ready for installation during the blockade. Also, additional panels were brought in via train and wagons during the blockade. And as you can see towards the left of the screen, the main lines are in operation with the ALO barrier in effect. And shortly, the camera is going to move towards the center of the screen to show the beginning of part 2, which is the removal of the existing gantry in preparation for the TS11 data change. As you can see there, you've got the exclusion zone, you've got the Kirov crane removing the existing gantry, and it quite quickly moves into part 2 with the removal of the down Filton main, and we'll quite quickly shift on to part 3, which is the removal of the main lines and installation of the main lines. And as you can see towards the right of the screen, you've got the filter and release in operation with the airload barrier in effect. So this video just gives a quick overview view of the staging strategy in effect.
So I don't know, this slide is just a summary of basically the blockade and some of the key figures, facts, and probably our most important fact was there were 0 safety incidents and 0 lost time accidents on the site. We worked over 170,000 site hours. In that time, we used 50 trains. There were only 7 complaints from residents over the 8-week period. We dropped a lot of tons of ballast, installed 238 track panels, 840 welds, and had 74 key-rod shifts. So it was a huge undertaking over the 8 weeks, and definitely felt tired at the end of it. But there's some of the key facts and figures of just the blockade. So some more drone footage. Now we're starting at Bristol Temple Meads, and we are working our way out of the junction. This was taken just at the end of the blockade, and you can see everything has now been installed. So all of the tracks, civils, infrastructure and signalling were all commissioned on time. The new walking routes were now in effect. All of the track had the LERPs installed during the blockade, and check rails were in as well. All of COPA adjustments were finished, and we managed to actually do the AMP15 paperwork and sign off the track and hand back to maintenance straight away at the end of the blockade. As you can see, as we turn through the junction onto the straight section, we've got the new gantry in play with the new signals on that with the cages around them. So this structure is now accessible and people can walk over them and go and maintain those signals in the cages, which they couldn't do beforehand. As we come up towards the gantry, you can see the new hedge shunt has been installed with the new friction buffer. The walking route has now been reinstated that connects into Barton Hill Depot. And as we go past the gantry to the left, you can see a kind of temporary scaffolding structure. That's our visitors spot where we had all of our visitors come in, so they weren't allowed on site during the construction works, but could see the site from a higher level, so to give a good understanding of the works when our VIPs came in. Also to the left, you can see we've got a walkable troughing route section with an elevated cable trough as well, which housed an 11 kV cable. And then we've reinstated the connections into Barton Hill Depot. And also to the right, Kingston Road sidings has now been connected with the new buffer installed there. And Kingston Road has been reconfigured for future operational use. And as the camera comes up to the top of the screen, we're now following the 4 tracks to Filton, and this S&C ladder was originally installed with plain line switches. So we've installed the switches now back now that the data change has happened, and this ladder now can be in operation going forward. As you can see, the site's tidy, all troughing was installed. We didn't have any issues with handback, so we handed it back safely on time with no safety incidents during the blockade. Right, so what we're going to do is just run through some of the engineering challenges and lessons learned. So firstly, the initial planning of this project, we had a requirement for the RAM where he said there is a requirement that modular panels are not to be used during construction. And this meant that the blockade looked like it was going to take about 12 weeks to install loose lay. So we came up with a solution with the RAM team and also our partners in SRSA and Progress Rail to say, actually, what was the problem with modular? And the problem was we were finding that, well, the RAM was finding that when he installed modular units over a couple of years, there would be issues with the spine panels, and that would cause gauge spread. So we came up with a solution called Modular Plus, and this meant that we would put through bearers in key critical locations, namely under the crossing nose, to tie the units together. So this was something that hadn't been done before. It's the first time it's been done in the UK. And what we would do, we would bring some through bearers on the back of a tilting train, drop them down on the deck, and then have modular panels with some of the split bearers removed and place them on top. And then tie the whole unit together, which meant that we could alleviate the RAM's concerns, but also meant that 90% of the junction was then brought in via tilting wagons, and that dropped the timescales down from 12 weeks of the blockade to 8 weeks of the blockade. So that's a major saving for us. And now Modular Plus is being rolled out nationally. They're changing the standards to update for Modular Plus, and this is the project that basically came up with the idea and put it through to fruition, and hopefully it will be useful for other projects going forward. One of the other challenges, I would say, that we had on the project was the existing Gantry interface with the new Gantry. So during the development, there was a slight error, and the gauging and OLE clearance wasn't taken into account for looking at the new gauging, the new Gantry structure. So during detailed design, we had to change the configuration of the signalling equipment on the Gantry. We worked very closely with the signal sighting chair and our civil structure team and Alstom to come up with a solution that didn't move the red aspect, but we needed to move the MARIs, the SARIs, the speed boards, the signposts all the way around the signal structure to allow for future OLE clearance and also to get gauge clearance as well. So that was a nightmare that happened late in the design development.
Another challenge was cable management. So the site is very constrained. So there's lots of S&C very closely packed together. But also we've got check rail areas, and we've got the platforms themselves. We've also got under bridges that restrict the use of UTXs. So to ensure that we provided cross-track protection to cables, ensured that we weren't creating any tripping hazards, ensuring that we were compliant with the relevant standards. NetRail acted as an integrator between all the different contractors, because there was lots of different contractors wanting to cross cables across our track. So we worked together closely to produce a strategy and a schedule that identified where these cables would be going, so we could plan in advance or through the design stage where we could place cable management sleepers, understand capacity needs. So we had enough capacity, but not too much. So making sure that we were also rationalising where we could save money. But also we had to consider the staging of the blockade as well. So with different parts of the junction being operational at different times, we had to understand where cables could actually go. And also undertaking this work, we also able to identify where we had potential issues with sort of clashes or very tight areas. For example, to the right screen underneath the gantry, we had lots of different assets from different disciplines in a very tight area. So as part of the cable management strategy, we had to identify where these cables would be going and making sure we were placing cable management sleepers in the correct and compliant position. Additionally, as I mentioned, we had to move a lot of cables across track near the platforms, of which a lot of these lines were check railed, and at the time there wasn't a way of conveying cables across track within a check rail section. And in this area we also had a lot of shallow ballast steps due to structures, so we weren't able to fit in a UTX. Fortunately, about a year or so before the blockade, a new product was approved from SHUAG, which was a new base plate that could be on a hollow steel sleeper, which allowed for the check rail to be attached. And this meant that we were able to place quite a few of these towards near the station, allowed us to protect our cables. So one for the future, should you ever be needing to cross cables under check railed areas.
We had a number of issues in terms of the blockade with signalling equipment. It probably was our biggest problem during the 8-week blockade, was installing 4-foot signalling equipment, just because we were running out of time. And also the testing of the signalling equipment took a longer time than we thought they would. We also, during the design stage, noticed that there were some areas where we had a standard track interval, so a 1970 interval, but because of the toes of the S&C being located very, very close to each other, the gauge clearance actually wouldn't allow for a standard size for a speed board to be installed, and this was due to end throw and centre throw being applied when you went through the turnout route. So we had to make a number of bespoke small speed signs that would sit within a standard track interval, and this was something that was done late in the day and caused a lot of issues with the signal sighting chair, because actually the signs were smaller than they thought that they originally would be. So that's one to think of if you ever have a lot of S&C in a congested area. Your 1970 track interval doesn't always give you the required space for signalling equipment.
Another challenge was platforms. So as we discussed, due to the amount of S&C right at the throat of the junction, we had to do approximately 25 to 100 meters of platform adjustments through the platforms. And this was a challenge as these platforms are very old, in very poor condition. There's a variety of different construction types that we had to adjust. Additionally, they were very non-compliant, mainly due to how tight the curvature is through Bristol and Tubbermead Station. So we had to work very closely with the gauge engineer, and we were able to utilise that it was not a reasonable opportunity to bring the full station into compliance. So we moved all of our offsets, crossfalls towards compliance. However, we did have issues through the station, specifically platform 13, which was delivered prior to the blockade. As you can see from the photos, there was a very large area that had a large mortar area, sorry, that was in very poor condition, and whenever we attached bolts for brackets or that sort of stuff, we found that it wasn't able to hold the load, and we found that it significantly impacted our construction our construction program. We had to actually remove a lot of this material and replace it, which, if that had happened during the blockade, we would never have been able to deliver all the civils works we planned. So we ended up doing a lot more testing, including pull-out tests, to understand if the existing station was able to actually, if we were able to actually attach these sort of brackets. And we found that doing this testing meant that we were able to de-risk the civils program, and we were able to deliver all of the civils work during the blockade.
Another area that was tricky and we had a lot of fun with was this area which we called the pinch point. So the photo to the left basically shows there's two sections of walkable trough that goes all the way down the edge of the underlying structure, and that gives access for drivers to walk into Barn Hill Depot. Now, because of the number of assets in there, and because Network Rail were the integrator of this project, we had signal cables, an 11 kV cable, the requirement for a walking route, hand points, signal signage, stop boards, etc., all that needs to be located in the same area. So we came up with a solution that the 11 kV would be put in an elevated trough, which would allow for 1 meter separation for the signalling cables, which is required by the standards. We used TTS system for walkable troughing route, which allowed for the troughing route to become a walkway. We did some strengthening works to the underbridge to allow for the stop signs to be put in, and the hand point for KPA, which is the turnout into the depot. The lever was reduced, and we had to come up with a different solution for us to be able to use that mechanical lever. In this area, we also had this temporary structure, which I discussed earlier, which was put in place for visitors to come and see the site, and being constructed without anyone being on site. And there was a large concern, because we were during the kind of COVID times, that we didn't want to kind of put any people in harm's way when they didn't need to be. So yeah, we had a viewing platform for everyone to come and see the site, which was safely segregated from the workers.
Another challenge was the amount of underlying structures which were positioned throughout the limits of the work. So as you can see, there's approximately 11 underlying structures within the limits, and then specifically just off the end of the platforms, we had a row of about 4 underlying structures that were all quite shallow, which were impacted both the design and construction stage. So from design stage, we had to ensure we were achieving compliant ballast depths, and if we weren't, we need to understand where we weren't, and if we were making sure we were putting in correct mitigation, or at least tried through design to remove those non-compliances. And then from a construction point of view, we were limited from a capacity point of view over a number of these structures. So we had to tailor the construction program, and this impacted the sort of size of Kiro cranes, where size of Kiro cranes we could use to move around the panels, but also where they could be set up. And we worked very closely with the RAM team to work on these things, and also we did extensive TBI and structural trial holes to inform both design and construction. Unfortunately, we did have an issue during Blockade where we found we had a shallow ballast depth over the NMS goods depot, which is a underbridge, and as you can see from the diagrams or the drawings, the old drawings, this was a steel deck structure that abutted a arch structure, and we found that during our structural trial holes, we had possibly not located the shallowest part of the structure. And we found that when we went out and did additional trial holes, that we were probably 20 or 30 mil shallower than we thought during the design stage. And this was maybe because we didn't hit sort of the main girder at the right point, as you can see from the drawing. And I think for me, lesson learned is trying to be a bit more strategic with our trial holes, and making sure we were identifying these shallowest points. Fortunately, we had mitigation in place anyway, just because of how shallow we were through this section, with undersleeper pads and geotextiles to help assist with the stiffness and stiffness transitions off the structures. We also took lessons learned from other projects. So 9 Elms had the incident with the collapse of the spandrel wall during construction. So we undertook an assessment of all the structures to understand if any of them were in poor condition and potentially posed a similar risk. And we did identify one structure that had a parapet that was in reasonably poor condition. So we worked closely with the RAM team, and they had actually identified this as needing work in the future. So we worked with them, and we were able to bring forward the works prior to the blockade, and we were able to use our access to get this fixed, so it was safe for construction work to take place near the parapet. And this meant that, one, it was safe, but two, it also meant that we were able to provide some value for money for the RAM as well.
So just to kind of end, some of the achievements and efficiencies that we managed. We handed back the blockade on time with the full scope delivered. There were no faults identified. The AMP15s and 16s were signed off for track within the blockade, so we handed basically the track back to the maintainer straight away. We reused materials where we could, so we used some of the track panels and sleepers and rail for some of the enabling stages in Kingston Road sidings, and also at the East Depot. At the depot itself, because we had to construct it in very tight timescales, we applied the principles of speed and pace, and our engineering team were given kind of delegated authority to sign off all designs without the required RAM signatures, and this was because the depot was temporary and was never going to be recorded in their asset database. We applied for over 20 deviations to standards during the whole project, but the main one we avoided, and I'm glad we did, was putting together a compliance report for the station, which deemed it wasn't a reasonable opportunity to bring all of the platforms into full compliance for X and Y throughout. And then one of the key things, and I think something that everybody on the project is kind of proud of, is we worked closely together, and there was cross-industry collaboration with all of our design and construction partners, but also TOX, FOX, station staff and RAM teams, to ensure that the surfaces were not affected as much as possible, and we managed to operate services throughout the majority of the blockade, only closing the station really with an all-line block for 5 days for the whole of the blockade. So that was putting our passengers first, and kind of one of the big key wins was we didn't have to close the station at all. So that's it. I'll open it up to any questions.
Thanks for that, Molly and Ben. Absolutely incredible amount of work there. It's superb, really good to see. We've got a couple of questions in the chat, so I'll ask those people to come in a minute. For those who haven't written any questions in the chat, if you do have a question and you can't be bothered typing it out, just pop your name in the chat and I'll bring you in when we get there. So first question, Mr. Adam Williams, are you there? Maybe not. Okay, I'll read out his question. It said, what were the main issues raised by residents and their complaints? Was it the usual dust, noise, etc.?
Right, so in Dings Park, which is the park where we had the temporary access, as luck would have it, there was I can't remember what his official title was, but he was basically an MP that had been relocated into Bristol city centre over the summer, and he was the main protagonist for complaints. He was there basically writing emails to Andrew Haynes and co on a daily basis, saying that the work was noisy. So we spent a lot of time trying to appease just one person. But at the end of it, he actually managed to come up onto the visitors platform and see the construction work for himself, and actually wrote an email back to Andrew Haynes apologising for him being a nuisance because he didn't appreciate the scale of the work that was going on. And actually, for the amount of work that was going on, it was very quiet. So that was it, noise really more than anything. But we had a kind of silent area where people had to come in and out of the temporary access and weren't allowed to speak. Radios weren't allowed on cars. You know, we had security on the access point. It was just bonkers. But I'm glad we only had 7 actual real complaints.
Yeah. Yeah, for such a massive undertaking, I guess that is pretty good going. Okay, the next question's from Chris Preston. Chris, are you still on the call? Would you like to ask yourself?
I'm still here. I'm still here, Nick. Hi there. Well, really interesting project and a huge amount of work. So well done to all the team involved in this. And one of the things that I've always been concerned with is when we have these great projects is the form of as-built information that becomes available after the project, especially whether there's any geospatially accurate data that's now being provided to feed back into the national database to update GeoRINIM or any of our other systems. So perhaps the team could explain what may have been done.
So basically, once the track was installed, we got the as-built saying it was within installation tolerance, and the line strings and the DRG files and everything went back into GeoRINIM so that could be uploaded. We also obviously update all of the different databases, ellipse, etc. And then some of the tight structures where we had like really tight clearances, they went out and got laser swept, and they were included in the national gauging database. But because the track was installed to installation tolerances, we're basically using the design files to give that data back. And that's all recorded in a 4D BIM model as well, which is kept up to date by the capital delivery team. I think one of the key things for us is understanding how that gets transferred into the kind of asset managers team and how they keep that up to date as works progress going forward.
Okay, thanks very much for a good answer. Thanks.
Thank you.
Don't have any other questions popped up at the moment, so I've got one for you. In terms of CSM compliance,
yep.
Were there any hazards you identified that you, through risk assessment, sort of designed out? Any specific design requirements to help design kind of key hazards out?
Yes. So all right. So the project is CSM significant and TSI compliant for infrastructure clauses. So during the design delivery, we tried to get the TSI compliance fully done, sorted for infrastructure, which was done. The major issue we had was gauging X and Y. And then in terms of just system-wide hazards, there was a lot to do with the signalling infrastructure and the interface of the existing and new gantry, and how that would work in terms of signal sighting. And for us, I think we tried to make the signalling design as simple as possible, albeit on a junction layout that has basically 50-point ends. It became a bit of a nightmare. So we used the BIM model to identify specific hazards, interfaces, clashing points, recorded them within the kind of hazard record, and then as the design progressed, tried to remove those hazards as much as reasonably practicable. And then when we didn't, we had the compliance evidence to show that, you know what, we still had either a fully compliant design or we'd reduced the risk as much as possible.
Okay, brilliant. We've actually got another question come up now, or maybe a couple of questions. Nigel Fletcher, if you want to turn your mic on. Oh, technical issue.
We just dodged a bullet there.
Yeah, I think you might have, yeah. I can see his mic turning on and off, but there's no voice.
Hi, can you hear me?
Yes.
Hello, hi. Sorry, I've just taken my headphones off. Yeah, hi, sorry about that. Nigel Fletcher from Arup. Hi, Molly.
Hiya.
So just to, firstly to echo the congratulations on a fantastic achievement and great presentation as well. Thanks for that. Two quick questions. The first is on the design of the layout. I mean, clearly from what you've explained, the complexities and the phasing and the success of the whole delivery was based on being able to build it in those phases. How much was the design of the layout based on that, or was there a design and then you worked out the sequence of how to implement it afterwards?
Okay, so the original kind of grip 3, grip 4 design started probably about 10 years ago and was done by NRDD, and they designed the final state flat layer. this is what it's going to look like at the end. Then that kind of sat on the shelf for a while because electrification was deferred, and we picked that up a couple of years ago and had a refresh of the end state layer. Then when we went into detailed design, AECOM became our design partners and were fantastic. And basically, they worked out the construction sequencing with the staging. So we had different packages for the enabling stages. So we had 5 different Form Bs for the enabling stages. And then we had basically Form B for the blockade that was split into different parts. So we'd have temporary alignments for tying into existing infrastructure or in the temporary state for the different sections of track that were installed. And then they were all built up to the kind of final layer that matched what was done at Grid 3.
Okay.
Does that make sense?
Yes, it does. Yeah. So so the design and the phasing kind of went hand in hand.
In detailed design, yes, yeah. So the actual staging kind of came first, and then we kind of agreed design parameters and how we were going to do different design packages to meet the staging for detailed design.
Okay. All right. Thank you. And my second question. You touched on the efficiencies on your last slide and on design and assurance. Yeah, things like the Network Rail project engineers, being able to sign off designs without RAM, on independent from the RAMs. I've got a question on self-assurance, and to what extent did you kind of have the efficiencies of the designers and the project team self-assuring their own designs? Did you do that at all, or was it all accepted by Network Rail in the traditional way?
It was all accepted by Network Rail in the traditional way. The temporary depot is where the Network Rail engineering team had the authority to sign off the designs, and that aligned to the simplicity of some of the designs that we were implementing at the depot. That was not, the complex big job of Bristol East. I understand that the business is moving forward to more of a self-assurance kind of way of the world, but it wasn't done at this point in time on this project, and I'm not sure if this scale of project would be able to do that. I think at least the DPE and probably the track and signalling would have had to have a layer of assurance within Network Rail, because it got very complicated at times.
Yep, I agree with all of that. Thank you. Thanks very much.
Seeing as there's no other questions, I've actually got another one. So, electrification. So you mentioned electrification was deferred.
Yeah.
How far advanced was the OLE layout, and for the new gantries, etc., when this design was put together? And has there been consideration for future electrification?
So the development of the design up to Grip 3 went hand in hand with the electrification scheme. Through Grip 3 to 4, there were changes to the alignment that were made. There were some issues with buffer locking calculations and stuff like that, which meant we needed to change the position and size of some of the units, and the toe positions moved around, but not drastically. So the old electrification scheme still has some weight, albeit it would need to be kind of reviewed and up-revved for the AFC design that we've got here today. Now, passive provision for electrification was tricky, especially with the new gantry going in. So we have allowed for an envelope for a pantograph to fit underneath that, with tolerances included for wind loading and all the things that are put in the D-gauge model. And also we have a 25 mil track maintenance lift allowance under that gantry structure. Albeit, I think the issue that's going to come is once the detailed design is developed for electrification, it's not going to be so much the structures, but I think it's going to be the wires that are going to cause a real issue with signal sighting, because we're on a tight radius curve going into the station, and the red aspects were fixed points, we couldn't move them. And working a OLE configuration around the signalling system, I think, will prove difficult, but it needs to be developed for us to get to that point.
Yeah. Okay. Thanks, Molly. We don't have any other questions, so just a couple of heads up for everyone on the call. First of all, thank you, Molly, Ben, again. For answering all the questions. Presentation fantastic, and you must be really proud of what's been done there. So thank you very much. A heads up, 23rd of March is our next section meeting. We've got a presentation on intelligent infrastructure, so slight change of tack. I just wanted to sort of also highlight that the PWI website has got details of all section meetings, and with this modern way of working, you can probably access some or all of those in terms of online. Also, for those who aren't aware, there is a PWI YouTube channel, so you can catch up on meetings that you may have missed. If you go on there, you can even entertain your family if there's nothing else on telly in the evening. There's some really good stuff on there. So I think we'll draw it to a close. Thank you all for dialing in. I think we were up to about 38 people at one point, so that's really great support. And thank you all. See you all soon.